In this lecture, we're going to talk about the shared responsibility model. Now, before we dive into what that is, I want to first talk about how we did security the old way before we had the cloud. So how did we handle security in a traditional on-prem deployment with a physical data center, physical infrastructure? The important thing to understand is, in this case, security is owned exclusively by you. So from the top down, you own all aspects of securing every aspect of your infrastructure and your application. So that includes things like securing your data center from a physical perspective, so only allowing authorized personnel to enter the data center. You wouldn't want any random people walking in and having access to your infrastructure. So you want to lock that down. So you're responsible for that. You're responsible for securing the networking within your data center, as well as making sure that connectivity in and out of your data center is secure. That can involve things like setting up firewalls and other devices of that nature. You will also then have to secure the servers that are running within your data center. And on top of that, you'll also have to secure the operating systems that are running on that data center. So that's going to include things like performing routine maintenance and patches and fixing any potential vulnerabilities that you experience over time. Then once you've got the operating system secured, you'll then have to secure your application that's deployed. So the application you deploy on that operating system has to be secure in itself, but there's going to be bugs there. There's going to be vulnerabilities. So you're going to have to make sure that you handle all security aspects of your application that's deployed on that operating system. And so what I want to highlight is that in a physical infrastructure, right, without the cloud, you own the security end to end. You have to manage all of this yourself. Now, when you're working with the cloud, things are a little bit different because you're now running on AWS's infrastructure. So now security is actually a team effort between you and AWS. So who exactly is responsible for what when it comes to a security perspective? Who's responsible for securing the physical infrastructure? Who's responsible for securing the operating system? Who's responsible for securing the application? So these are all things that we need to figure out. Now, when it comes to figuring out who's responsible for what, the shared responsibility model was created. And the purpose of the shared responsibility model was to delineate the customer's responsibility from a security perspective versus AWS's responsibility from a security perspective. So who's responsible for what? And that's the whole idea behind this model. It's supposed to tell you what you're supposed to do versus what AWS is supposed to do. So if we take a look at the shared responsibility model, and at the bottom, we could see what AWS is responsible for. So they're going to be responsible for the physical infrastructure because we're now running our stuff on their physical infrastructure. We don't have access to it, so it's their job to secure it and lock it down. So they have their own data centers scattered across the globe. They're going to make sure that they're secure, and they have several different constructs to kind of define their infrastructure that we have access to. So things like regions, availability zones, and edge locations, all of these things, which you guys aren't familiar with yet, but we will cover that in the next section. But all of these things are going to be secured by AWS. And they're going to secure all of the compute power, the storage, the database, and the networking needs of their data center. They're going to be responsible for all of that. Whereas for the customer, which is us, we're going to be responsible for everything outside of that. So usually at the operating system level, so we'll have a server that runs on AWS. We're responsible for securing the operating system, not AWS. AWS will secure the server and it'll secure the underlying infrastructure, but we're going to own the operating system and up. So we're going to own that. We're going to own the network and firewall configuration, any client-side encryption. That's all going to be done by us. And when we go to deploy applications onto AWS, we have to secure our own applications. AWS doesn't know anything about our application, or we're going to have to handle all of that. And any identity and access management, we're going to have to handle that ourselves. So any data that's associated with our application, anything that is associated with anything that we deploy, we're going to be responsible for. But all of the physical infrastructure is going to be handled by AWS. Now, an example of infrastructure as a service would be something like EC2. All it is that AWS just gives you a virtual machine in the cloud. You could do anything with it. You can select whatever operating system you'd like, but they give you a virtual machine. So they're providing the physical infrastructure, the compute power, but you own everything else. So that's an example of infrastructure as a service. If we go to like a platform as a service, we've got things like AWS Lambda. And AWS Lambda is cool because if you have an application, instead of having to spin up a server and set up the operating system and set up the firewall, upload your code to that server, AWS Lambda just allows you to upload your code and then AWS handles everything else. So they handle everything from the physical infrastructure all the way through the operating system and everything else that your application needs, everything but your application source code. So that's kind of an example of a platform as a service. AWS is owning a little bit more responsibility than they would be with a traditional infrastructure as a service. And then finally, we have software as a service, which basically, AWS or whoever's providing the SaaS is going to own everything except for the application data. So your customer data, things that you actually input into the application itself. So things like Workmail, Amazon Chime, WorkDocs, these are all examples of software as a service that are provided by AWS. Security and compliance. So what is compliance? Well, when an organization works in specific industries, they're going to have to adhere to certain rules and laws specific to that industry. And this is especially true for finance when you're dealing with, bank accounts, credit cards, as well as healthcare, or if you're dealing with federal government and you are storing potentially sensitive information pertaining to the government, there's going to be a lot of rules and laws that you have to abide by. And this also applies to where your organization is located. So every country is going to have their own set of rules and laws that you have to abide by. And it's important for you to understand everything that must be met for you to actually operate your business. And so compliance and regulatory frameworks are sets of guidelines and best practices that organizations must follow to meet regulatory requirements. Now, a couple of examples of these would be, if you're handling credit card information, you're going to have to comply with the Payment Card Industry Data Security Standard, or PCI DSS. And so this is a security standard that was created for organizations that have to handle any kind of credit card or any of the major card brands. It's really just there to help protect the credit card holder information so it doesn't get leaked. So you have to follow certain rules and regulations. And so all of the banks, credit card payment processors, other vendors, they all have to comply with this regulatory requirement so that they can actually properly and securely handle credit card payments. And if you've ever worked in the healthcare industry, specifically in the US, we have what's called HIPAA. And so HIPAA was created so that we have to make sure that our health information is secure. We don't want our health information getting leaked to other people. It's meant to be private information. So, hospitals, different providers, emergency rooms, all of these different organizations that work with medical information, they have to follow HIPAA standards to make sure that patient information is actually secure. So these are just a couple of examples, but you'll see that in most industries, there's some sort of compliance or regulatory framework that organizations do have to follow to ensure that data and information is secured and isn't going to cause any potential issues for any of their customers or any other organization. So when it comes to compliance in the cloud, right, we're now running our infrastructure on the cloud. And so AWS is going to have to meet certain compliance and regulatory requirements because their customers are going to work in a variety of different industries. So they could have customers that work in banking, finance, healthcare. So whatever regulatory requirements those customers have to meet, well, AWS has to meet those as well because they're the ones running the infrastructure. And so now it's a team effort. Compliance, just like security, both you have to be compliant as well as AWS. AWS does a very good job of making sure that they regularly get audited and that they meet a variety of different common regulatory and compliance frameworks. So AWS actually undergoes audits and verification reviews by various governing bodies to ensure that they are compliant with a variety of different regulatory frameworks. And reports of these audits can actually be downloaded from a service called AWS Artifact. And so there you can take a look at all the reports to make sure that AWS is HIPAA compliant if you're working in the healthcare industry. And you could take a look at the report of their specific audit within the service. And also within the service, you can also review, accept, and track the status of various AWS agreements. So if you, your company itself, are also getting audited, you may be required to show that the infrastructure that you're running your application on is also compliant. So you could just log into AWS Artifact and take a look at AWS's audit report for that specific regulatory framework. Now, AWS has this really cool web app or website called the Customer Compliance Center. And so this is a one-stop shop to being able to kind of research and get information about a variety of different, cloud-related regulatory requirements and how they impact the specific industry that you work in. So at the Customer Compliance Center, some of the things that you can do is you can identify specific regulatory requirements. You can actually search based off of the country that you're operating in to see the different laws that have to be met and the different rules that you're going to have to make sure you follow. You can discover how other companies in your industry have solved a variety of different compliance and governance challenges. AWS is going to answer some key and common questions that other customers may have asked for. They also provide a auditing and security checklist, as well as reference architectures with best practices. Now, when you deploy resources onto the cloud and your organization has to be compliant with different regulatory frameworks, you're going to have to make sure that all of the services, all of the resources also meet those regulatory requirements. So let's say we've deployed a couple of resources to the cloud. And let's say our organization has to be PCI and CIS compliant. Well, we have to make sure that each and every one of those resources is both PCI and CIS compliant. So we'll have to continue to log in, verify the configuration, and check all of the resources and verify that they're compliant. And keep in mind that your infrastructure can be quite complex in the cloud, and having to manually go in and verify all of those things is a very cumbersome and tedious task. So AWS has actually created a tool to help simplify that process. And so AWS created the Audit Manager, which continuously collects data from all of your deployed resources in the cloud and verifies if they have met specific regulatory and compliance requirements. So if you need to be PCI and CIS compliant, well, you could tell Audit Manager, okay, I need you to check all of the resources I've deployed in my account and verify that they're both PCI and CIS compliant. And you could do this with any of the other regulatory frameworks like HIPAA or any of the other ones. You just tell which regulatory requirements or compliance that you have to meet, and Audit Manager will check each and every one of them and make sure that they're compliant. And if for some reason one of them doesn't meet compliance, well, then Audit Manager will notify you so that you can go and fix it and make sure that it's back in compliance. In addition, since Audit Manager is already auditing all of your resources, you can use Audit Manager to build audit-ready reports. So if your company or organization has to perform some sort of audit, you could just log into Audit Manager and generate a report just to make sure and show that whoever needs to know, you could just say, hey, look, all of the services within AWS are meeting these regulatory requirements. Now, one other tool that I wanted to go over before we wrap up this section is called AWS Config. So what AWS Config does is it actually tracks and records all the changes made to an AWS resource within your account. So let's say that you have a virtual machine in the cloud or an EC2 instance. Let's say that we decide to add a security group to it to allow HTTP connections. Well, that change that we just made there is going to be documented within AWS Config. It'll say, okay, we attached a new security group. And then if we attached a volume, right, then it's going to say that we attached an EBS volume at this specific time. So it's going to track how we've changed the configuration of all of our resources. And we get to see kind of like a big picture of how our resources have changed over time, because it's going to track each and every time we've made a change to it. And this is great for, regulatory requirements or for auditing, because since we have historical data, which keeps track of all the configuration changes of resources, it's going to be great for audits because we already have all that information being collected within AWS Config. So let's quickly recap what we learned in this section. We learned that compliance and regulatory frameworks are a set of guidelines and best practices that organizations must follow. AWS is actually fairly frequently audited, and the reports for these audits can be accessed from a service called AWS Artifact. The AWS Compliance Center is a central location to research cloud-related regulatory requirements and how they impact your industry. Audit Manager will continuously collect data to prepare for audits and ensure that you are achieving compliance with a variety of different regulatory standards. And AWS Config will monitor the configuration state of your AWS resources over time. Identity and access management. I want to start off by going over the steps needed to create an account, because it's actually kind of important when it comes to identity and access management. So when you create an AWS account, you're going to have to provide 3 pieces of information. So first, you're going to have to provide a unique email. And so when I say unique email, that means if I make an AWS account with my email of kodekloud@gmail.com, you're not going to be able to create a separate account with using the same exact email. So you need a unique email. You give the account a name. In this case, I just gave it a name of dev. And then you're going to have to provide a credit card. Now, you can technically use the same credit card across multiple AWS accounts. The important thing that you have to understand is that the emails have to be unique. And when you create an account, one user will automatically get created for you, and that's the root user. And so the root user is kind of like the most powerful user in your AWS account. It can perform any action it wants. It has access to all resources within the account. It can create anything, delete anything, and it can view anything. So it's really the King Kong of all accounts. And just to reiterate once again, if we tried to open up another AWS account using the same email, it's not going to work because we have to provide a unique email for each AWS account. Now, what happens when a new employee joins the organization? How do we give them access to your AWS account? How do we give them access to AWS resources? How do we authenticate him? And how do we also limit down what he has access to? Because maybe we want him to allow him to have access to certain resources, but not other resources. And so this is where identity and access management, or more specifically IAM, comes to play. So this is the service that's responsible for identity and access management, allowing users to, connect and be able to perform a variety of different operations within AWS. So when it comes to authentication and authorization within your AWS account, you're going to be making use of a service called IAM, which is Identity and Access Management. So IAM manages who has access to what in your AWS account. So they handle the authentication process as well as the authorization process. So not only do we verify who someone is, we also have to verify what can they do within the AWS account. And there's 3 types of identities that you can create within an AWS account. There's users, you have groups, and you have roles. And don't worry about what the differences between those 3. We're going to go over them, but I want to make sure you guys learn what all 3 of those things are by the end of this lecture. But there's one other thing that you have to learn when it comes to IAM, which is called policies. And so policies define, what resources can a user or a group or a role have access to and what actions they can perform. So these are the 4 things that I want to make sure you guys learn by the end of this lecture. Now, IAM kind of acts like a security guard for your AWS account. So it's going to be responsible for managing access to the things that are running within your AWS account. So if a user or a group or a role try to perform some sort of action, first of all, they're going to have to authenticate with IAM. So they're going to have to verify they are who they say they are. And then on top of that, using policies, we can define what they can do within your account. So maybe you have a policy that says, okay, you can work with service A, but you can't work with service B. And so that's where policies come into play. And that's part of IAM as well. So IAM does 2 things. It handles who is authenticated and what are they authorized to do. So that's really the whole purpose of IAM. So let's go over what IAM users are. Now, when a new employee joins the organization and they need access to AWS, you're going to have to create a user account within IAM so that they can have access to AWS and a subset of services. So really, an IAM user just represents a person or application that needs to access AWS or a subset of services within AWS. And so for every employee or person that needs to be able to work with AWS, you're going to have to create a different IAM user for each one of them. And I want you to keep in mind that you don't just create users just for humans or for like actual employees. You can actually create IAM users for applications that may need access to AWS or needs to interact with AWS. So it's not just for humans. It can also be used for your applications that you deploy onto AWS. Now, after creating a new user in AWS, by default, they cannot access anything in AWS. Now, you might be thinking that might be a little counterintuitive. Why do we create a user if he doesn't have access to anything? Well, that's just by default. So this is meant to be kind of like a security measure. So anytime a user needs to be able to perform some sort of action within AWS, they have to be explicitly given permission to be able to work with those resources and perform those actions. So you can't just create a user, you have to create a user and then give him permissions to be able to do very specific tasks, because you don't want a user to be able to just do anything within your account, because that could be a little bit of a security violation, because then they could potentially take down your entire infrastructure, and you want to make sure your employees only have access to what they need to have access to. Now, to grant users permissions to access resources, you're going to have to make use of another feature called IAM policies. And so a IAM policy is just a document that either grants or denies access to a specific service or resource. So you can create a policy that says, okay, you cannot access EC2, but you can access S3. So it's just a set of rules saying what you can and what you can't access. And you'll find that these rules can be very granular. So it's not just accessing a specific service. You could even go down to the specific action of a service. So maybe you can only create S3 buckets, but you can't delete S3 buckets. And so policies are very, very flexible, but you want to make sure that you follow the principle of least privilege, which means only give the bare minimum access to what your users need. So if a user doesn't need to work with EC2, well, define a policy that doesn't allow them to work with EC2. They don't need to have access to it. Don't even give them the permission to. It's always much safer to only give them access to what they absolutely need. So this is an example of a policy document. And so I'm going to break down line by line what each one of these statements and configurations actually does. So for the first thing, we've got the version. And so this is going to define the version of the policy language you're using. So for this, you just go to the IAM documentation and just figure out what is the latest version, which happens to be this one at the time of recording. Then you have statements. So these are going to be all of the different rules, and this accepts a list of rules that you want for this specific IAM policy. And we'll take a look at the first rule. And in the first rule, you have a SID, which is a statement ID. And this is just an optional identifier for your policy statement. So you could, provide something descriptive like, allow all users to access EC2 or something like that. You just give it some name that makes it a little bit more human readable. Then you have the effect. So this can either be an allow or deny. And so this is just going to determine what the policy is actually doing. So in this case, it's an allow, so it's going to allow the user to do something. But if it's a deny, then it's going to say, okay, the user cannot do something. The action is what we are allowing it to do. So in this case, we're saying we're allowing the user to do anything EC2 related, but you can get really granular with the different actions that a user can do or cannot do within these policies. And then you have the resource this is applying to. So we're saying that we want to allow the user to perform any EC2 action. And we're saying the resource this should apply on with the little asterisk means any resource. So this rule is going to apply to any resource within AWS. And so that's the gist of a policy statement. It's really got three things that you want to focus on, right? The effect, which is going to be allow or deny. So do you want to allow the user to do something or do you want to deny him? Then what actions are you either allowing or denying? And then on what resources should that action be applied on? And that's it. So if we take a look at the next one, you can see we got this one called third statement. The effect is allow, so we're going to allow the user to do something. And under actions, we're going to allow the user to perform a list on S3. This is going to list out all the S3 buckets. And then it's going to allow get operations on S3, which means it's going to allow the user to retrieve objects from S3. And then the resources is going to provide a list of in this case, S3 buckets that the user should be able to perform a list or a get operation on, which in this case happens to be only bucket 1. All right, so we've created an IAM policy. So what exactly do we do with it? Is that all we have to do? Not exactly. So when you create a user, as I mentioned in the previous slide, users by default do not have access to anything within AWS account when you create the user. And you have to assign an IAM policy to define what that user is allowed to do. So you attach the policy to a specific user, and now the user inherits all the permissions defined in the policy. So if the policy says, okay, you can't access EC2, well then he can't access EC2. And if the policy defines that he can access S3, then he can access S3. So remember, you create users, and then you assign policies to the users, and then the user gets the permissions that are defined in the policy. Now, I mentioned this before, but I really want to hammer home this idea. And that is that when you give permissions to users, you want to make sure that you only give permissions that the user needs. So if the user needs to work with S3, then you allow that. And if they don't need to work with EC2, then make sure that you set up the permissions to not allow that, to deny EC2. And you can get even more granular with that. So instead, if you know that the user should be able to create an S3 bucket, but they shouldn't be able to delete it, then go ahead and allow them to create an S3 bucket, but also set up a rule that doesn't allow them to delete. Right? You want to make sure that users are only granted the minimum permissions necessary for them to perform their job. And this is called least privilege permissions, right? Only allow what they need, nothing more. Now, every time we create a user, we're going to have to remember to assign a policy to that user so that he has the necessary permissions to do his job. And every new user, you're going to have to do the same thing. And it can be difficult to kind of remember to always assign the same policy over and over again. So if you have a bunch of users that should have similar policies, you can make use of something called groups. And so groups are nothing more than just a collection of IAM users that ideally are going to have similar IAM policies. And what they allow you to do is you can assign policies to the group, and then when you take a user and assign them to the group, guess what? They inherit the policies. And so that way, when you create a new user, all you have to do is assign them to a group, and they're going to inherit all of the policies. So that way you get a brand new member that's going to join the IT team. Okay, just add him to the IT group, and he'll have all the correct permissions by default. So it's a little bit quicker and more efficient than assigning an individual policy for each and every single user. Now, the final identity I want to talk about is roles. Now, just like we can assign a policy to a user, we can assign a policy to a role. So what is the purpose of a role? Well, a role allows a user to assume it. So what that means is the user can temporarily act like that role. And when he assumes a role, what happens is he inherits the permissions of the role. So maybe the user by default doesn't have a lot of permissions, but while he's assuming the role, he gets to inherit more permissions to be able to perform other actions. And then once he's done, he can then revert back to his original policies and permissions. I like to think of a role kind of like when you have a family. And so normally in the family, the parents are responsible for making all the decisions. The father or the mother or both of them are in charge. But let's say that the parents go out on a dinner. Well, while they're out, the oldest son decides to assume the role as the parent, so now he's kind of responsible for all of the children. He gets to make all the decisions. He gets to decide what they eat, what time they go to bed. And then once the parents come back, well, he gives that role right back up and he goes back to being a child. So that's kind of how a role works. It just allows you to assume or borrow permissions of that role for a short period of time. And so IAM roles are recommended when you need to grant access to a service on a temporary basis, right? You need to know that for the exam. So usually when you want to grant permissions or access to a service for a short period of time or temporary basis, you can use roles for that. So let's now talk about multi-factor authentication. So normally when you try to log into AWS, you're going to provide your credentials, which is going to be your username and your password. And if your username or password ever gets leaked or a hacker gets access to it, then he can now access your account as you. So what you could do for extra security is you can make use of multi-factor authentication, and you can have a code get sent to your multi-factor authentication device or app, and then you can provide that code to AWS to be able to log in. So now if a hacker is ever able to get your credentials, he could try logging in, but at the end of the day, he won't have access to your multi-factor authentication device, and so he won't have the code and he won't be able to log in. So it's just a little bit of extra security that you can add to your account, especially since you're dealing with AWS. If somebody were ever to hack your account and get in, well, guess what? First of all, they can delete your production application, or they could even rack up a massive bill and you could wake up with a very, very large bill that you weren't expecting. So you definitely want to make sure you enable multi-factor authentication. And there's different hardware devices that you can use as your MFA device, or you can use apps on your phone. And so some of the more popular apps are like Google Authenticator or Authy. And so the way that these apps work is that you open the app and then it's going to give you a code on there, and then you just plug that code in. And that's basically how multi-factor authentication works. So it's just that extra security level because now they would need to have access to your phone or your MFA device, which most likely they don't. Now, one more thing to note about multi-factor authentication, which is that you have to enable it on a per user basis. So that means you would have to enable it for each one of your users manually, or you can have it disabled for some of them. But I definitely recommend that you enable it for all of your users because you wouldn't want any of your users to get compromised. So just something to keep in mind for the exam, and just in general when working with AWS, each user is going to have to manually enable multi-factor authentication so that they all have that extra security. Now let's summarize everything we've covered in this section. First of all, when you create an AWS account, it's going to automatically create one user for you, and that's the root user. And the root user has unlimited access and no restrictions. And you want to make sure that you don't really ever use this account. Instead, you want to create a separate user account and use that. Because remember, if for some reason this account ever gets compromised, they have full access to your account. So you definitely want to avoid doing that. Now, IAM is the service that's responsible for managing access to AWS resources. A IAM user represents a person or application that needs to access AWS or a subset of services. And policies are documents that either grant or deny access to specific AWS services and resources. Groups are a collection of IAM users, and you can assign policies to groups so that all of the users within that group inherit those policies. And roles allow a user to get temporary access to a service or a resource. And finally, least privilege permission. You want to make sure you grant users or entities the minimum level of access required for them to perform their specific task, which reduces the risk of unauthorized actions or potential security breaches.